Okay, we're recording now. So we're talking about writing bash scripts. And so in the previous lecture, I mentioned that bash allows, or bash has, these things called parameters. So bash calls all variables parameters. Parameters are, the parameters that use a symbol as the name are called the special parameters or the positional parameters, which I'll show you in just a second. So the symbols star and at and hashtag, question mark, hyphen, dollar, exclamation mark, and zero. Believe it or not, these all correspond to parameter or variable names in bash. We're going to use some of these later on in the course, but I just wanted to mention that, or show you the documentation for them. It's also linked in the notebook. So in that blue box, if you click on these links, you'll see it'll take you to that documentation there. All right, so we've seen that many commands in bash require that the user provide some, or either require the user provide some input or allow the user to provide some input. And so these are what called the command line arguments. A shell script can access the command line arguments provided to it. So first of all, you need to know how many command line arguments are given to the script. So that's stored in the parameter hashtag. And the actual command line arguments are stored in the parameters called 1, 2, 3, 4, and so on, up to 9. If you want 10, you have to do something a little bit special. There's also a parameter number 0. So I'll show you what parameter number 0 does in just a second. So there's a little script called viewArgs that illustrates the use of number, or hashtag, sorry, and the positional parameters. And so all it does is it's a script. You pass it 0 or more arguments to the script, and it simply prints out the arguments. So there's an echo statement, right? So echo prints a string. So much for this lecture. Okay, back to the recording. So we were looking at this script called viewArgs. So there's an echo statement that prints a big string, and so the string looks like that. So it's all of that inside the double quotes. So the number of arguments is stored in the parameter called hashtag. And so to access the value of that parameter, you need to put the $ in front of it. So $hashtag is the number of command line arguments provided to the script. The first command line argument provided to the script is stored in the parameter called 1. So if you want its value, you need to write $1. To print out $1, notice that the dollar is special, right? So I have to escape the dollar here when I print out the $1, the literal $1. Right? The actual value that's stored in the variable or parameter 1 is given by $1. Right? And then it prints out the second command line argument and the third command line argument, and so on and so on and so on, up to the 10th command line argument. Right? So notice that if you want the 10th argument, the 10th command line argument, you have to write it this way. So you need to write the $, followed by some braces, followed by the number 10 inside. If you write if you write $10, bash thinks you want command line argument number 1, followed by a 0. So append a 0 to the end. Right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you don't have to do anything special. If you want anything higher than 9, you need to put the number inside of the braces. I don't know what the limit is, how many command line arguments your script can, if there's a maximum number of command line arguments that a script can take. Right. And so that's the contents of the script. Now you might ask the question, well, what happens if you only pass it one command line argument? Right? What happens to this $2, $3, $4, and so on and so on and so forth? And so we might as well just look and see what happens. Okay, so it's called viewArgs. So there it is. So to run the script, you just type /viewArgs. And so I'm going to pass it no command line arguments, so 0 command line arguments. And so the script runs without any errors. So it says there are 0 command line arguments. It says the value stored in the parameter called 0 is that. So that value there is how you ran the script. Right, so I ran the script by typing in /viewArgs.sh. So that's the value that's stored in the parameter 0. If I go up a directory, and I want to run view args, I need to write dot/introduction, right? I need the path to the script, right? So notice that the value of 0 changes to how the script was run. So 0 stores, it's not just the name of the script, right? But it's actually the path. It was the how the script was actually run. Okay. There. All right. So notice that for the value of 1, there's nothing. The value of 2, there's nothing, and so on and so on and so forth. Right. So we'll come back to that in just a second. ABC. So I'm going to run it with one command line argument now. So now there's one command line argument. Right. The value stored in parameter 0 doesn't change. Right. And the value stored in 1 now changes to the first command line argument. Right. If there's 2 command line arguments, right, now that shows up in the second one shows up in the parameter number 2. Right, and if there's 3 command line arguments, GHI, right, that one shows up in parameter number 3, and so on and so on and so on and so on. Right. If you use more than 10, there's still no error. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 command line arguments. Right. It stops printing at the 10th command line argument. But the script actually did receive the 11th and 12th argument. Right? It just doesn't. It's not using it for anything. If you wanted to pass in the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 all as one string, of course you have to quote it. Right? So wrap everything in double quotes or single quotes in this case would be fine. Right? And now there's just one command line argument that is the string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so the rule in Bash is you are allowed to access the value of an unset or non-existing variable. Right? So here, when I ran view args the first time with no arguments, there is no value stored in parameter number 1. Right? It has no value. But you can still access the value of that parameter without error. And so Bash creates variables as you use them. So it's much like Python in this case, right? Except it's the difference compared to Python is if you try to access the value of a non-existing or unset variable, Bash simply uses the empty string for that value instead. Right? And so what this script was actually printing here, right? So for 2, it prints out the empty string. For 3, it prints the empty string, and so on and so on and so forth. Right, so notice it's not considered an error to attempt to obtain the value of a parameter that is not set. Right, it is perfectly reasonable. It is a perfectly acceptable thing to do in Bash, and it leads to all sorts of hard-to-find bugs in your code. Right, so you can imagine if you have a variable that's spelled like a long. You have a variable and you misspell it. Right, the misspelling of the variable doesn't cause an error. Right, Bash will create the variable for you. Right, the misspelled variable for you. And it'll use the value of the empty string for that variable. So you have to be a little bit careful when you're writing your Bash programs, right? It's very easy to make mistakes, and those mistakes can be very hard to find. Okay, so now that we can get the value of a command line argument, we can modify, or we can write scripts that use the command line arguments. So remember we had this script called make shell, so that one, right? So that script makes an empty Bash script for you, sets the permissions of the script so that it becomes runnable for the user, and it saves the script in a file called temp.sh, right? It would be nice to save it in a script specified by the user, and so that's what named.sh does. Right? It's the exact same thing. This one contains a bug, but we'll get to that in just a second. Right? So named.sh expects one command line argument, right? And that's the name of the script to create. Right? So named.sh what do I want? I already have a myscript.sh, so my new script.sh, right? So run that, list the contents of the directory, and you see there's a newly created script, right? If you look at the contents of the script, it contains the correct first line of our bash script, right? It's green, so you know that the user has execute permission on that file, right? So we have execute permission on that file. And so there's an example of using a command line argument in a script for a, well, semi-useful purpose in this case. Does anybody see the bug in the script? There's actually two, but it's the same bug. Yep. There's three errors. Sorry. Yeah. So if you don't provide a command line argument, that's also an error. That's not the one I was thinking of. Sorry. So let's run it that way. Okay. So now you get now there's an actual error. So you get ambiguous redirect, right? Because the value of $1, the value of parameter 1 is the empty string. So you're redirecting to nothing, which bash doesn't like. Right? And then you're trying to change the permissions of the file whose name is the empty string, which again, bash doesn't like. Right? If you pass in no command line arguments, that's a problem. So we should try to address that. There's a second problem. Anybody have it? All right. So expects the name of the script. So my script.sh, right? If you run it that way, it seems to work, right? It doesn't complain. There's no issues, right? The naive user might expect that there be a file called my space script.sh, right? But if you look inside the directory, there isn't. There's just one called my, right? If you look at the contents of my, right, there's the line. There's the first line of our script, right? The permissions of my are the user has execute permission on the file. So what's happened here is that bash thinks that's two command line. Bash thinks that that is two command line arguments, right? There's a space between the my and the script. So that actually works the way we'd expect it to. So that's not actually the bug. The problem is when you write this. Right? So you say, well, okay, so I mean, so I understand why I got the file called my. So I know that because of word splitting, I have to quote the input, the argument, so that there's one argument passed to the script. Right? And when you run that, now you get a second error. Right? And so now it says you have another ambiguous redirect. Right? And it also says it cannot access script.sh. And you think, well, that's weird. Right? So what's going on here? Right. So when you pass it in a argument that has a space in it, right? Remember, $1 is the value of the argument. So that is the string my space script.sh. Right. So what does bash? So all of what's highlighted there gets replaced with my space script.sh. It doesn't get replaced with the quoted version of the string, right? Even though we quoted the string as the argument, right? The value of the string is my space script.sh. So when you do the substitution, you have a redirect to, it looks like two files, which you're not allowed to do, right? So this redirects to the file called my, then it complains that there's something else after the my, and then when it tries to change the permissions of the file, right? It's not trying to change the permissions of the file myscript.sh, right? It's trying to change the permissions of the file my and of the file script.sh, which is why we had that, which is why the error for change MOD complains it can't find the file script.sh, right? So to fix the script, you have to quote the accessing of the variable value. Right? So you probably, I mean, I haven't explained to you exactly. Well, so when I talked about quoting, I did say that when you do parameter substitution, the double quoting does not stop. Double quoting does not prevent parameter substitution. Right. So there, we substitute the value of whatever's stored in parameter number 1. Right. And now whatever's stored there, now that gets double quoted. Right. So if you pass in a string, like my space script.sh, this now becomes the quoted string my space script.sh. Right. When you try to change the permissions of the file, it's now the correct file name. Right. So it's now the quoted my space script.sh. Right. Without the quotes, word splitting happens. With the double quotes, word splitting does not happen. Right. And so this is the correct version of the script. I don't think the notebook actually mentions this. Pretty sure it doesn't. So one of the examples here is hello you. So it's the hello world script, but instead it expects one command line argument, and it sticks in. So it expects the name of the user, right? And so it sticks in the name of the user here. Notice that this is all in double quotes. So it doesn't matter what you type in for the command line argument. This will always work correctly. Right? I don't think it manages. I don't know. It doesn't say anything about that. Yes, here it is. So here's name shell in the notebook itself, and it's the buggy version that's in the notebook. Right? So remember, whenever you're accessing the values of these variables, right, you probably need to double quote them. Okay, so we'll come back to that when we talk about parameter substitution in detail. All right. So any questions about making a simple bash script? Right. So the idea is pretty simple. You make a text file, right? First line of the file should always be hashtag or shebang root bin bash or root user bin env space bash. Contents of the script, save the script. Make sure you have execute permission on the script. When you run the script, make sure you specify what directory the script is in to run it. All right, so that completes that notebook. Oh, I guess the next notebook is how to use variables in bash. So it's called variables. It's really parameter substitution, though, right? So this is one of the expansions that bash does. All right, so bash says that so in bash, a variable is a parameter whose name begins with a letter. Right? You can just call them variables. You don't have to call them variables parameters. I really don't care, right? A parameter is what most of us think of as being a variable, right? Except it's allowed to have a funny name in bash. I don't think the user is allowed to create their own parameters. So you're not allowed to use the funny symbols to make strange variable names. This just describes the naming conventions of variables that I use in the course. Basically, it's always letters, numbers, and the underscore. Okay, so everything in bash, all data types in bash are strings. Right? That's the end of that's more or less the end of the story. Right? You can have an array of stuff, but it's always an array of string. So bash variables are essentially strings. Depending on the context, bash will interpret the string as a number, right, as an integer. So for example, if you're doing a numerical comparison or an arithmetic operation, bash will reinterpret the characters of the string as numbers and symbols. No floating point arithmetic. If you need floating point arithmetic, you have to use some command to do the arithmetic for you. So much like Python, there's nothing special that you have to do to make a variable. You just make the variable and away you go. Right? Everything's a string, so you don't even care about typing. So there's no special syntax for declaring a variable name. Bash creates the variable for you when it's first used. Right? To assign a value to a variable, it's just the equal sign. There's no spaces around the equal sign. Right? Remember, the space is special to bash. Right? It's the token separator. So if you stick in a space here, it'll complain, and I'll show you that in just a second. Right. So here are some examples of making some variables, right? Very simple examples. A equals 2 means A stores the value 2. Right? More precisely, it's the string 2. Right? B equals some string. Okay, so B now stores the variable, the value some string. That's string concatenation for you right there. right? So $A means get the value of A. Sorry, $A means get the value of A, replace $A with the value of A. So that becomes 2. Right? $B means get the value of B, replace everything that's highlighted with the value of B. So that becomes some string. So all of this becomes 2 some string, right? Which looks bizarre the first time you see it. Well, probably even the 10th time you see it. But that's just the way it works in Bash. Right? So if you run this, everything's fine, no errors. Right? If you look at the values of the variables, A and B should not be surprising. Right? A is 2. Right? B is some string. And C might be the only surprising one. Right? It's 2 some string. All right, so don't forget, so when you're creating the variable, there's no $sign, right? So on the left-hand side of equals, there's never a $sign, right? $sign means get the value of, right? So here we want to set the value of the variable. You just use the variable name. On the right-hand side of the assignment operator, if you want to access a variable, you need to specify, you need to tell Bash that you're accessing the value of the variable. $variable name. You can also use $brace variable name, right? And so the one that I highlighted is the one that's guaranteed to always work. Right? So if you want to, you can always write $brace var variable name inside the braces. That's guaranteed to always give you the correct result. That almost always gives you the correct result, except when it doesn't. So I'll give you an example of when it doesn't in just a second. Yes?
So Bash these variables as strings.
Yeah, everything's a string in Bash. Oh, you don't have to here. So if you run that, it's fine. So, but it's fine because you have to be careful here. So what's the value of $C in this case? Well, it's 2 followed by some string, followed by a space, followed by a string, right? So it's actually, so the value of C is actually 2 some space string. Right? So when I print this using echo, that's actually what you're passing into echo, right? And so if you type that in on the command line, echo to some string, right? That does what you want it to do, maybe, right? The reason this works is because, so there's actually 2 arguments that are being passed to echo now. So echo prints each argument with a space in between. Right? If B was actually that, this no longer works the way you want it to. Right? So now, right, again, right, so when you do the concatenation into C, C is 2. So the value of C is going to be 2 some, lots of spaces, string. Right? But when you echo this, right, Bash does word splitting on this, right? So all of those spaces get collapsed into one, and you get and you get that, right? You don't get 2 some and then lots of spaces followed by string. If you want the lots of spaces, right? In other words, if you want to preserve the value of C, you have to quote it, right? And now you get the spaces. Right? This is this is a bit of a tricky one to catch, right? You have to be aware of the fact that echo will accept more than one argument, but it prints each argument with a single space in between. Yes, doesn't matter. Sure.
If you wanted a space variable, so it's
Yep. Sure. Yep. Like that. Okay. There's another, or you can do it like this. Well, let's run it and see if I'm actually correct. So run that. Whoops. Let me put this back to the way it was. So run that, and then run that, and there you go. Right. You can also do it. Anything that suppresses the meaning of the space will work here. Right. So you can also do it that way. And that also works, right? What you cannot do here is single quoted. Right? So if you single quote it, remember what single quoting does. Single quoting takes away the special meaning of everything inside the single quotes. So now you get that. Right? So it's either double quotes or the escape character to escape the space. Yep. Question over here? Okay. So let me put that like, whoa, like that. All right. Oh, I guess so. That question also explains why you need single quotes and double quotes, right? You can't just use single quotes because single quotes takes away the meaning of parameter expansion, right? And often you want to access the value of a variable inside of the quoting, right? So I want to replace. I want variable expansion to happen inside the quoting, so that's why double quoting is there, and it doesn't suppress the meaning of parameter expansion. Okay, so I think I explained this in a previous lecture. The use of the dollar sign in front of the variable name is weird if you come from Python or Java, right? The reason you need it in Bash is because Bash is a much older and a simpler language. So by simpler, I mean it's simpler for the computer to read, to read and interpret what you're typing in, right? And so when the variable name appears on the right-hand side of the equal sign, Bash just thinks it's a string. And so it needs the dollar sign in front of the variable name to force it to get the value of a variable rather than treating the name as though it just were a string. Right? In your modern programming languages, like Java and Python, they use more sophisticated parsers. So the program that reads your file is able to infer the meaning of the fact. You want the variable name on the right hand. You want to access the value of the variable on the right hand side of the equal sign. All right. So when you write this dollar something, that's parameter expansion. Right? You're getting the value of a variable. You can always use, again, you can always put the name of the variable inside braces. Right? So this one prints welcome user. Right? Not surprising. On most Unix systems, user is a variable that actually stores the username. So if you write $user here, you get, in this case, I get welcome Burton. Right? On your machine, you'll get welcome whatever your username is. Right? Okay, so there is, again, that string concatenation. Right? Access the value of A, right? Access the value of A and replace everything that's highlighted with the value of A. Right? Access the value of B, replace everything that's highlighted with the value of B. So that's string concatenation. We already did that, and we did that, and we, oh, right. And so when you print out A, B, and C, you're always printing out $A, $B, and $C, right? The value of A, the value of B, the value of C, of the value stored in the value in A, the value stored in B, the value stored in C. C looks funny because we changed it to single quotes. Right? If you just write A, B, and C, well, you get the strings A, B, and C. Right? So again, this is why Bash needs the dollar sign, right, to access the value of the variable. Yes. Why when you need the braces around the? I'm going to show you an example in just a second. Yeah. I think it's here somewhere. Yes, it's coming up. All right, so the reason you might need braces around the variable name is because of the fact that Bash creates variables when they are first used. Unlike many other programming languages, it's not an error to attempt to get the value of a variable that has not yet been declared, which is annoying, right? So here, I do not have a variable called y in my in the shell that the notebook is currently running in. Right? We haven't made y yet, but you can write y equals $y, no problem. It'll work, right? In fact, right? It does exactly that, right? So y is undefined the first time this cell is run, right? You might think that getting the value of y is an error, given that y hasn't been declared yet, but it works just fine. Bash creates the variable. I'm not 100% sure if it makes the variable y here or not. What I do know, though, is that if you try to access the value of an undeclared variable, you get the empty string instead. Right? So here, you get, x gets assigned the empty string. Right? And then, when you print out x, or the value of x, well, you print out the empty string. Right? The notebook says it creates the variable y. I'm the one who wrote the notebook. I'm not 100% sure if it actually makes y here or not. You do, however, get the empty string here, and there's no error. Right? And so you have to be super careful here. Right? If you misspell the use of a variable name, the script's going to run. You're not going to get a warning or anything like that. And now debugging your program becomes very difficult. All right, so because bash creates variables for you when you use them, every once in a while it's necessary to wrap the variable name up in braces instead of just writing $var. Right? Okay, so here consider the following script called badbackup.sh. Right? So this one expects one command line argument. It also shouldn't be written like this, but never mind. Okay, so this one says in is equal to $1, right? So whatever the first command line argument is, that gets assigned to in. You really shouldn't write it like that. You should write it like this. You never have to quote the variable in a simple assignment, right? So if you want to access the value of the variable in a simple assignment like this, that doesn't need to be quoted, even if it has special characters in it, right? This works just fine unquoted. All right, now it's the next line that causes the problem. Right? So first line, we make a variable called in. Second line, we make a variable called out. Right? What value do we assign to out? Well, it looks like I'm going to grab the value of in, right? So if in is my file, right? We're expecting this to become my file, right? Underscore dot BAK, right? And so I'm using underscore dot BAK to create a copy of the file that is a backup of the file, right? How do I make the copy? Well, I just use the CP command, right? So I copy whatever was the file name given by in, which was the command line argument to the script, right? And I save it to the file name that's given by the value of out, which is hopefully in followed by an underscore followed by dot .bak. So if you run this from your terminal, yep, okay, so if we run this bad backup. Oh wait, I have to back up something. So we'll back up bad backup, like that, right? So if you run that, and you look at the contents of the, should I have not have, perhaps I should not have done that. No, that's correct, right? In dot back. Oh, there it is. Okay. So when I did that, I didn't see the hidden file, right? When I use the -a, I do see the hidden file, right? So notice that there is no, we expected this thing to make a file called bad underscore backup underscore dot, bad underscore backup dot sh underscore dot BAK, right? That's what it should have done, right? Instead, what it's done is it's created the file dot .bak. Right? If you look at the contents of that file, it's exactly, right? It is a copy of that file there, right? But it has the wrong name. Right? And so the question is how on earth did it get the name .bak from this? Right? That looks like it should have been the first command line argument, right? Followed by an underscore, followed by .bak. It's not. Right? What's happened here is, remember, you're allowed to use the underscore as a variable, as part of the variable name. So bash thinks you want to access the variable in underscore, which doesn't exist, right? So what is its value if it doesn't exist? Well, it's the empty string, right? So the name of out is .bak, right? And so now it copies the input argument file to .bak, which is exactly what we got back here, right? So why did it happen? Right. It's because bash interprets the variable name as being that, right? Underscore is a legal character in a variable name, right? Dot is not, right? So when bash tries to access the name, the value of a variable, it's going to suck up as many characters as it can to figure out what the variable name is that you're trying to access, right? It'll stop when it encounters a space or some character that's not allowed to be part of a file name. Some character that's not allowed to be part of a variable name. Right? And so it tries to access the value of the variable in underscore, which is not what you want. Right? So here's the explanation for all of that. Right? To correct the problem, right? There is where you have to wrap up the use of the variable inside of braces. Right? So when you use the braces around the variable name, bash knows you're trying to access the value of the variable stored in, right? And then it knows you want to append underscore dot BAK to the end of it, right? And so it's often the underscore character that causes the problem when you're trying to access the variable name. Right, you're trying to do some sort of string concatenation. The thing that you're concatenating to the end of the first string starts with an underscore. And now it looks like to bash that you're trying to access a variable name instead of doing string concatenation. Right? So there's an example of where you have to be careful and use the braces around the variable name. All right. So when you use a parameter expansion, oh wait, let me see if this is corrected or not. This could still be, some of them can be stored. Okay, so did I fix this? Do not occur, okay. This used to be buggy. I think this is okay now. All right, so when you do an expansion, you can store, you might be able to store the result in a variable. You can't store all expansions in a variable. So here's brace expansion, right? So remember that thing right there is a brace expansion, right? That gives you the strings good, space, bad, space, ugly. There's a prefix, so it actually gives you the string the space good, space the bad, space the ugly. Right? There's a brace expansion giving you a sequence of numbers. That's a file name expansion that gives you all of the file names that end in .ipynb. Right? That expands to my home directory. That's parameter expansion, so it expands to the value some string. There's arithmetic expansion, so that expands to the value 3. Right? So if you run this, it looks like, so when you run this, you get what you expect. You get the good, the bad, the ugly. You get 2020 through 2029. You get all of the notebook files that are in the directory this script is running in. Right? For the tilde, you get my home directory. For x, you get some string. And for the arithmetic expansion, you get 3. Right? So some of those strings can be stored in variables if needed. Right? So in an assignment statement, so x equals something, values on the right-hand side of the equal sign undergo, right? So on the right-hand side, tilde expansion, right? So if you have the tilde, you're going to get your home directory name. They undergo parameter expansion, right? They undergo command substitution, and they undergo arithmetic expansion, right? But notice what's missing here, right? Brace expansion is missing, file name expansion is missing, right? So on the right-hand side, if you try to use a brace expansion, right, the expansion doesn't happen. Right? If you try to use a file name expansion on the right-hand side of an assignment sign, the expansion doesn't happen. Right? So there's my brace expansion. I'm going to try to store I guess the whole thing is a brace expansion technically. I'm going to try to store that in the variable called movie. Right? Again, another brace expansion. I'm going to try to store those values in the variable years. File name expansion, I'm going to try to store all the file names that end in IPYNB in the variable notebooks. So if you run this, doesn't work, right? So instead of getting the expansion, the good, the bad, the ugly, right, you get the string equal to that, right? Instead of getting the years 2020 through 2029, you get the brace 2020 dot dot 2029 dot dot 3, right? Instead of getting all the notebook files, you just get the star dot IPYNB, right? So if an expansion doesn't happen, you just get the literal string, right? So for notebooks, it's just that. For years, it's just that. And for movie, it's just that, right? The expansions never actually happened. You have to be super careful when you run this example, because if you misplace the quote, suddenly, oh wait, sorry, I guess that didn't, I guess you don't have to, I guess you do not have to worry about that. This should print the good, the bad, the ugly, no? Oh no, sorry, never mind. I'm storing it in a variable. I'm being dumb, never mind. Okay. All right, so the results of tilde expansion, parameter expansion, and command substitution, and arithmetic expansion, you can all assign those to a variable, right? So they do happen on the right-hand side. Right? So there's tilde expansion. There's an example of parameter expansion, right? I'm going to get the value of x, stick it on to the end of this is. There's a command substitution, right? I can store that in a variable. There's an arithmetic substitution. I can store that in a variable. Right? When I print out those values, they all work, right? Like that. Right? And so the fact that bash doesn't perform all expansions on the right-hand side of an assignment is a little bit confusing. You have to remember that it happens. You have to either remember which ones happen and which ones don't, or you have to look it up every time you're trying to do it, right? Yeah, so that's one of the, I guess, awkward things about using bash, right? You have to remember that there's a whole bunch of expansions. Some of them happen sometimes, and some of them don't. Right? And so there's accessing variables. Sorry, this is actually the simple accessing variables. There's another notebook that talks about something else. So when we talk about strings, there's yet more to parameter expansion that we need to talk about. But there's the basics of accessing and using variables. Any questions about the contents today? All right, so I think that's good for today. Before we go, there may or may not be a lecture on Thursday. I'm not sure yet. So I will post an announcement on OnQ letting you know either way. Right. All right, so we're done for today.